Hi everyone, in this lesson we're going to be looking at all the simple rules of differentiation that you've learned. And what it's really about is you getting comfortable with learning, what rule to use when. And so what I would recommend is that you just go ahead and try to do all these on your own, and when you're ready, come back and check your work. So number one, it looks like the best rule to use here would just be the chain rule. I certainly don't want to move that trinomial to the denominator and then expand it. So we're just going to use the chain rule. So we're going to do -5 times the coefficient, which would be -15. And -5 minus 1, that's -6, times the derivative of the inside. We don't want to leave a negative exponent in our answer, so we're going to rewrite this. All right, and that's the answer for number 1. With number 2, I think all we need to use is the power rule. The only thing I would suggest doing first is just rewriting the root x to x to the 1/2 power. Now we're all ready to go to use the power rule to differentiate. -4/5 minus 1 is -4/5 minus 5 over 5, so that's -9/5. And we don't want to leave negative exponents in our answer, so we'll rewrite this now. And that's the answer to number 2. Now with number 3, you could use the quotient rule, but I don't know about you. I'd rather not use the quotient rule if I don't have to. So what I'm going to do is I'm going to simplify this first. And I'm just going to divide x into each term. So we have 4x cubed divided by x. That's going to give me 4x squared. And then we have x divided into 8. I could just rewrite that as 8x to the -1. And now I can just use the power rule to use differentiation. And then we'll just make sure that we don't have any negative exponents in our answer. And that's it for number 3. Number 4, again, I definitely do not want to have to use the quotient rule, so I'm going to rewrite this. Instead of 1 over x squared, I could just write that as x to the -2. The next term I can write as 2x to the -1. And now I'm all ready to differentiate. And we want to just rewrite it so we don't have negative exponents. And that's it for number 4. With number 5, same idea. I'm going to rewrite the first term. Right? It's all about making our lives as easy as possible. We want to find the easiest route to differentiating. Now I'm ready to go. And I'll just rewrite it without negative exponents. And that's it for number 5. All right, number 6, we have the product, so I'm going to use the product rule. We have f, we have g, and I always recommend writing it out. So y prime is going to equal f g prime plus g f prime. And then just be careful for the derivative of f, we'll need to use the chain rule. So we have the derivative of the outside times the derivative of the inside. And now we're going to simplify this. First thing I'm going to do is rewrite it a little neater. I think rewriting it helps finding the GCF a lot easier. So first we're going to compare the 2 and the 40. Actually, the 2 and the 40x. So the GCF there would just be 2. And then we have this 5x squared minus 4 to the 4th power, and over here we have 5x squared minus 4 to the 3rd power. So 3 is less than 4, so that's the one we're going to write. Now we're going to compare what we pulled out to the original term, and it looks like we need to add a 5x squared minus 4. And if you're not sure, what you would do is you would say, is it true that this times this brings me back to the original term? Right, now we're going to look at the next one. We're going to compare the 2 and the 40x, so we're going to need to add a 20x. And then we see that we have an extra guy right here, so we have to write that. And when we compare this to this, they're the same, so there's nothing else to add. Again, what we want to do is we want to just double check, is it true that that, or GCF, times what's in here is going to be bringing me back to my original term. Now I'm going to simplify what's inside here. And we're going to distribute the 20x to the binomial. So 20x times 2x is 40x squared. 20x times a negative 3, that's negative 60x. So what we end up with is 45x squared minus 60x minus 4. So our final answer, 2 times 5x squared minus 4 cubed times 45 x squared minus 60x minus 4. Now if you want, you could take it one step further and you could multiply the 2 times every term in here, but either answer would be fine with me. All right, number 7, the obvious one to use would be the quotient rule, but you could also rewrite this and use the product rule. I'm going to do it both ways so you can see. So first I'm going to do it using the quotient rule. So I'm going to write out the quotient rule. We're going to simplify the numerator, and you don't have to FOIL out the denominator. We're going to multiply 4x by the binomial, so 4x times x is 4x squared. 4x times negative 3 is negative 12x. And then just be really careful that you distribute the negative to both parts of this binomial. So we're going to end up with minus 2x squared plus 1. And the last step, we'll simplify again. All right, so that's our final answer, and that is using the quotient rule. Now, you can also use the product rule. A lot of people like the product rule better. So we just would have to start by rewriting the function here. So we're going to rewrite that as 2x squared minus 1 times x minus 3 to the negative 1 power. So these two mean the same thing, but now I can use the product rule instead. So the product rule says that I have f g prime plus g f prime. We'll just fill that in. All right, I'm going to write that a little neater before I take out the GCF. All right, now I'm ready to write my GCF. I'm comparing the two terms and I'm seeing what I could pull out. So I have a negative and a 4x. There's nothing similar there. This guy is not repeated over here, so I can't pull that out. But I do have an x minus 3 to the negative 2 and an x minus 3 to the negative 1. So I'm going to pull out the exponent with the lower value. Negative 2 is less than negative 1, so that's going to be my GCF, x minus 3 to the negative 2. And then we're going to compare what's extra here that's not in my GCF. So I've taken care of this. I need to put the negative, and I need to do the 2x squared minus 1. And again, I'm going to compare this to this. I need to add a 4x. And then I need to decide what my exponent will be on my x minus 3 binomial. And you're saying negative 2 plus what number gives me negative 1. and that would be 1. Remember, when we're multiplying and we have the same bases, we're adding the exponents. So we have to make sure, I'll say it one more time, that -2 plus this value brings me back here. Now we're going to simplify what's inside. We'll simplify it again one step further, and then we'll write this without the negative exponent in our final answer. And you can see that we did get the same result that we got originally when we used the quotient rule. Now, I think I would much rather use the quotient rule in this case. A lot of people do prefer the product rule. The only problem is when you use the product rule, in this case especially, you have to do that whole GCF process, and a lot of people don't like that. So it's really just up to you what you choose to use, and quotient rule works just as well as the product rule and vice versa. All right, so lots of practice, just you deciding now what to use and getting comfortable with all these different rules. Thanks for watching. Have a great day.